Okay, so now let's try to answer the last question. Does the pH of 12.52 make sense in our titration curve? When we add 80 ml of the 0.1 molar NaOH, the pH value is at 12.52. To solve this problem, first we need to determine the amounts of base we add in our solution. Okay, so now we'll say moles of NaOH added, okay, which we have 80 ml times 0.1 molar, that you get 8 millimole. Okay. From our initial problem setup, we have 40 ml of the 0.1 molar HCl. So we can once again also determine the moles of HCl in the solution at the beginning. 40 ml times 0.1 molar, that gives you 4 millimole. Looking at these two numbers, you realize that we add more strong base than the acid available in the solution. So our solution at the end should be basic. The pH value should be greater than 7. But what will be exactly the pH? Well, we need to determine the concentration of the OH minus. Since we're given NaOH, which is a strong base, the amount of NaOH left in the solution will be the amount of OH minus in the solution. Therefore, we know that the moles of OH minus equal to 4 millimole. Just take the difference between these two numbers, you get 4 millimoles. And now to calculate the concentration of OH minus, we will have 4 millimole divided by the total volume. This is the new volume, which will be 40 ml plus 80 ml. The 40 ml coming from the fact that I have 40 ml of the HCl at the beginning, the 80 ml of the NaOH minus solution we add, and take the ratio of the two numbers, then you get 0.033 molar. Okay. Once I know the concentration of the hydroxide ion, I can calculate the pOH value, which is the negative log of the concentration of hydroxide ion. So I take the negative log of 0.033 molar, and that will give me 1.48. But we're not done yet. We're almost there because we know pOH value, but the question asks you the pH value. That's another relationship we learned, that pH equal to 14 minus pOH. That means we have 14 minus 1.48. That will equal to 12.52. So it makes sense that if we add 80 ml of 0.1 molar NaOH, our pH value will be 12.52. So that answers the last question. To recap of what we just talked about, a titration of a strong acid by strong base, let me write down the chemical reaction first. So we have HCl plus NaOH, making NaCl plus H2O. Okay, so looking at the titration curve, before I add any strong base, all I have is just strong acid, HCl. So that's why if you're looking at the picture molecularly, we will have just mostly HCl molecules. As we start adding strong base in our solution, the strong base will neutralize the acid in our solution, but we haven't added enough strong base to neutralize all the acid in our solution. So what we have, we still have some remaining HCl plus the salts that we produce, NaCl. At the equivalence point, once again, the equivalence point means the number of moles of OH minus equal to the moles of the H plus in our solution. So this will be 1-to-1, they completely neutralize each other. So at the equivalence point, all we have is NaCl plus H2O. And NaCl is a neutral salt. It will not change the pH. So at the equivalence point, the pH value will be 7 when we do a titration of a strong acid by a strong base. After the equivalence point, that means we have no more HCl in our solution. So by adding more NaOH, that means we have excess amounts of OH minus and extra NaCl in our solution. So that is the recap of titration of a strong acid by a strong base.